Welcome. Let's get straight into this. In this chapter, I would help you build acquaintance or awareness on certain questions on under current electricity. Please note our classes are done in three phases. If you come across this video, this is the first phase. This is just to build acquaintance, so at least you go don't come across the question or you don't know the question. You see how they set the question. The next phase is the drill phase, is done on WhatsApp, and the last phase is our speed test phase, is also done on WhatsApp. You want to be part of the class? I'll leave a link in the description box of this video for you to enroll. Let's dive straight into it. The first question here: two resistors. That one has to do with demonstration. Number two, demonstration. Number three, in order to convert galvanometer into an ammeter, what do you need? What do you need? You need right, to convert a galvanometer into an ammeter, you need a low resistance shunt connected in parallel. You need a low resistance shunt connected in parallel. Next line, right, to convert a galvanometer to voltmeter, you need a high resistance cord multiplier connected in series. They ask those questions a lot, so we are going to encounter that one too. Number four, calculations. 5, 6, 7, 8. 8 has to do with calculation. 9, 10, it also has to do with a little bit of demonstration. 10, the same thing, so you make something subject of formula. See, but let's read through it. And a cell has an open circuit voltage V1 and a closed circuit voltage V2 when the current I is flowing through it. Therefore, the internal resistance of the cell is, let's see, the internal resistance of the cell going to be V1 minus V2 over I. Option D. 11. According to Ohm's law, the ratio of V, which is voltage, over I, which is current, is constant for silver. Right. Silver is a metallic conductor. Hence, it obeys Ohm's law. Next line also writes, not all electrolytes are ohmic conductor. Not all electrolytes are ohmic conductor. So 12. Which of the following is not an effect that can be produced by an electric current? That can be produced by an electric current. Heat can be produced by electric current. Light can be sound motion. Option E, none of the above. Because, right, you can convert electric energy to heat energy, light, sound, or even mechanical energy. So none of the above there. 13, 14, 15. The resistance of an open series circuit is the resistance of an open series, something that's open, no current flows through it. Right, in an open circuit, no current flows through it, and hence there is no resistance in the opposing in the part of the current. So nothing. 15 has to do with 0. 16. Which of the following circuits calculation? 17, 18, 19, 20. Calculations. Most of the questions on these chapters are demonstrative questions. They have been solved already on a sheet of paper. Okay, that one too, that series is done completely different. 21, 22, 23. In the circuit shown in the figure wasn't even given. Most times students come across this in the exam hall. They see in the circuit shown on the figure and they're not going to even give the circuit. A lot of them will ask me, so sir, how we go take do one? Well, the thing to do is to first skip that one and go to the ones where they use the entire data of the question is complete. 24, calculation. A lot of the questions here are calculation based. For resistance, 25, supposed to be four equal resistors. Alright, so 4 resistors, R1, R2, R3, and R4 are connected in series as shown in figure 9 below. V1, V2, and V3 are voltmeters connected as indicated. You see the voltmeters. Which of the following relation is correct? The relation that's correct here, there should be a demonstrative part to this also. This is because V1 is equal to V3, V2 is equal to V4, just V1, sorry, just like R1 and R4. So V1 is equals to V4, V2 is equals to V3. So you will get V1 equals V2 over 2, V1 equals V2 over 2, V1 equals V3, sorry, V1 equals V3 over V2 over 2, option A. But there's a demonstrative part to it, which has been done on the notes still. The resistance, similar thing, 26, 26, 27, 28, 29, 30, 31, 31, 31. Which of the following will convert milliammeter to a voltmeter? Remember, high, connected in watts. 31 is option C, connected in series. 32. Which of the graph A to E in the figure represent the current voltage relationship for a cell with internal resistance? 32 is option C. 32 is option C. 33, 34, 36, 37, 38, 39. A lot of the questions here has to do with calculations. Okay, and that's good. This is the main chapter on electricity that has a lot of calculations. 44. A calibrated potentiometer is used to measure the EMF of a cell because right, a potentiometer has an advantage over a voltmeter in measuring the EMF of a cell. And I want you to rule a table. On one side, right, voltmeter. Voltmeter measures EMF in closed circuit as the cell delivers current to the circuit. Number 2, it takes current from the cell. Number 3, the pointer is prone to reading error. The pointer, pointer, is prone to reading error. Next, it measures EMF inaccurately as it measures as it may have zero error. So voltmeter do have zero error. Next, right, potentiometer starts. It takes no current from the cell. Number 2, it measures EMF with precision. Number 3, it does not use a pointer, so it's not prone to parallax error. And lastly, it measures EMF in open circuit when the cell delivers no current to the circuit. So 44 is option, let me see which of them. B, potentiometer takes no current. Option C, it takes no current. Potentiometer takes no current. In the above circuit, wasn't given 45, 46, 47, 50, 49. The total energy required to send a unit positive, that's 48, right? The 49 rather. 49. The total energy required to send a unit positive charge around a complete electrical circuit is electromotive force. Right. EMF is said to have done work around the circuit. So the electromotive force is said to have done work around the circuit. So that's the total energy that is required to send the unit positive charge around a complete circuit is called EMF, option C. Next, right, potential difference is the energy expanded or the work done across any 2 points of a circuit as a unit positive charge is transferred between them. Which of the following graph of current against voltage illustrate Ohm's law? 50, option A. 50, okay. 54, which of the following obeys Ohm's law again? 54, which of the following obeys Ohm's law? All metals, right. All metals are ohmic conductor, meaning they obey Ohm's law, including liquid metal, which is mercury. 54, all metals, option D. 55, calculations. The circuit diagram contains 4 ammeter W, X, Y, Z. Which of the following statement about the ammeter reading is correct? The same current. We go through them. Let me see. The readings of W and Y. W and y are equal, and each is greater than that of x. They are greater than that of x. This w and y, they are equal and they are greater than that of x. Option C. Write for me now, jot a note down. I would hope you draw this circuit. The same current passes through W, Y, and Z. Hence, they have the same reading. They have the same reading. They have the same reading. 58, 9, 60. Enough questions to solve here. That's good. Love it. Which of the following is required to convert a milliammeter to an ammeter? High resistance connected in series. High resistance 64 is option B. 64 is option B. Abi? 1 minute. Let me check where 64. Low resistance connected in parallel. Okay. Ammeter, milliammeter to ammeter. Okay. Option C. Low resistor in parallel. 65, 66, 67, 8, 70. A lot of questions here. Calculation. 72. A cell of internal resistance 0.01 ohms can be measured accurately using a potentiometer. 72. Potentiometer. So it measures more accurately. Okay. Next, calculations, and more calculations, and more. In the diagram above, what would happen to the current I if another resistance R2 is connected in parallel to R1? 83, you have to do with a bit of demonstration. 83 has a bit of demonstration behind it. 84, 85, 87, 88. All the questions on these chapters have to do with calculation. You barely have less than 30 questions that you don't need solvings. 101. Which of the following obeys Ohm's law? Metals obeys Ohm's law. Option B. 101 is option B. Option B. 101 obeys Ohm's law. 102. When a charge moves through an electric circuit in the direction of an electric force, it does what? It loses potential energy and gains kinetic energy. It loses potential energy and gains kinetic energy. 103. To convert a galvanometer to a voltmeter, high resistance connected in series. 103. Option A. We've done that one now like 4 times already. So you see what they repeat a lot. When resistance is constant in a circuit, the electric current is, what will happen to an electric current? The electric current would be directly proportional to the potential difference. Option B. Next, when a galvanometer is connected in series with a multiplier, it functions as a voltmeter. Option A. It functions as a voltmeter. Now, right. And when it is connected in parallel with a shunt, it functions as an ammeter. That will be that, and that will be the last one under the theoretical part. I gave a little bit of note. This note won't be more than up to even a page. Snap and send them to our WhatsApp group. Please note, we run classes. You want to be part of the class, I'm going to leave the link to the group in the description box. From there, you could also get to chat me up privately. For those who are preparing for entrance exams and also UTME, post-UTMEs, etc., and A-levels. Thanks for studying with me. God bless you. I'll see you in the group.